6.3. Solve linear systems by adding or subtracting. In this lesson, I'm going to show you how to use adding or subtracting to solve linear systems. You can also call this method the elimination method. The first thing you do is to add or subtract the equations to eliminate one variable. So I'm going to show you this example right now. So I'm going to take 2x plus 3y, and I'm going to line it up with negative 2x plus 5y equal to 13. And then it seems like it's going to be easier to eliminate 2x and negative 2x by adding these two equations. So 2x plus minus, so this would be minus 2x here, will become 0. Plus, no, this would be plus 5y plus 3y, so 8y. And positive 13, so plus 11 would be 24. Then the second step would be to solve the resulting equation for the other variable. So y would be your other variable. It will be 3. Substitute in either original equation to find the value of the eliminated variable. So I'm just going to use the first one and recopy it down here and substitute 3 in for y. So 2x plus 3 times 3 equal to 11. This will be 2x equal to 2, and x would equal to 1. And then your final answer would be 1, 3. Part A. Solve the linear system by using adding or subtracting. So in this case, you have decimal numbers. That's okay. I'm going to eliminate 1.8x by using subtracting. 1.8x subtract 1.8x would be 0. So I cancel that out. So right here it's subtraction, negative, positive, negative. So now I'm going to take negative 4.2 and add negative 7.5. And that would give me negative 11.7y. And here again, I'm going to take negative, positive, negative. So again, negative, or the subtraction sign, positive 42.9 would give you a negative 42.9. So now, negative, negative. Then we have to add both negative numbers to get negative 58.5. And then we can solve for y. And then after you simplify this, you should get y equal to 5. And then I'm going to use the first equation to sub in 5 for y. You can use either one, it doesn't matter. So this would be 21. And then 1.8x. We need to add 21 to negative 15.6. And that would be 5.4. And x would be 5.4 over 1.8. And that would give you 3. And then your final answer will be 3, 5. Okay, and you will write it as a coordinate. Okay, for this example, you have fractions involved, but that's okay. I'm going to line up 2/5 y. So I'm going to write it right here. And then plus 1/5, I'm going to line it up with this one, 4/5 x. And then this will be equal to 11. And it's going to be an addition inside. And I'm going to choose to subtract because I want to eliminate 2/5 y. Negative positive will give me a negative 2/5 y here. Therefore, this will be canceled out. In a sense, you're like multiplying a -1 to the entire equation. So this 1/5 will become negative. So 4/5 subtract 1/5 will be 3/5 x. Negative positive 11 will give you a negative 11, so 14 minus 11 gives you 3. And x will be 3 times 5/3. This is canceled out. So x would equal to 5. And then now I can take 2/5 y plus 1/5 times 5 to solve for y. This cancels out to be 1. So 2/5 y plus 1 equals 11. 2/5 y would equal to 10. Y would equal to 10 times 5/2. So that would be 25 for y. So my final answer, I will write 5 for the x value and 25 for the y value. Okay, let's take a look at another example. In this case, you need to rewrite both equations in standard form. So this would be 3x minus 3 equal to y plus 5. And then that would give you 3x minus y equal to 8. We'll set that aside and we'll take care of the second one. 5y minus 5 give you 3x plus 15. And I'm going to move these around. So let's see, minus 15, so that's going to be negative 20. And then 3x minus 5y. Okay, so now I'm going to use the elimination method. I noticed that both equations have a 3x. I can eliminate that by lining the equations up. I'll rewrite both equations right here. So 3x minus y equal to 8. 3x minus 5y equal to negative 20. Okay, I'm going to use a subtraction sign, or it can also be taken in as a negative sign. So then I could do 3x minus 3x to eliminate one variable. And then negative makes a positive 5y here. So positive 5 minus 1 will give you a positive 4 coefficient y. And then negative times negative here will give you a positive 20. So positive 20 plus 8 gives you 28. And when we solve for y, it will become 7. Circle this. And now we're going to have to solve for x. And I'm just going to use the first equation, 3x minus 7. I'm going to substitute 7 in for y. It's positive. And then we'll set it to equal to 8. So 3x equals to 15. And then x will give you 5. And then I can write my answer as 5, 7. For the second case, you have one equation that has denominators, so we're going to have to use the LCD of 5, 2, and 1 to eliminate the denominators. So it will be the LCD will be 5 times 2 times 1, so that's 10. So 10 times m over 5 will be 2m. 10 minus n over 2 will be minus 5n. And then 10 times 2 will be 20. And here we have two terms that are the same in each of the equations. So I will rewrite this one down here so I don't have to rewrite the first equation again. Okay, so now I'm going to choose to use subtraction again to eliminate 2m. So 2m minus 2m is 0. Negative, positive, negative. So negative 5 minus 3 is negative 8n. Negative, positive, negative. So 20 minus 4 is 16, and n gives you negative 2. I'm going to box this, and I'm going to plug in negative 2 in for n into the other equation. Well, you could plug it in either equation, but this one, the second equation, is easier to work with. So 2m 10m equals to 5. So your answer will be, let's put it in alphabetical order, just like xy. So this is nm will be negative 2, 5. Okay, for this next problem here, you have 3 equations with 3 variables, so it's just a little bit more complicated, but then we can still manage this. So first, I'm going to rewrite this as z equal to 4 minus 3x plus y. I'm going to set it aside. Okay, now I'm going to substitute z for the other 2 equations. So this would be 2x plus 3y minus, I'm going to take this and substitute it in here, 4 minus 3x plus y. So basically I am combining the elimination method and the substitution method right now to solve for this system of linear equations. And this one will be x plus y plus 4 minus 3x plus y equal to 6. Now I'm going to simplify this, the second and third equations. Okay, so I'm going to bring it down here. This will be 2x plus 3y minus 4 plus 3x minus y equal to 12. And now we can combine like terms. 2x plus 3x is 5x, plus 3y minus y is plus 2y, and then negative 4, I can move it over to the other side of the equation. So that will give you 16. Okay, and then now we can do the second equation. So I'll rewrite it. X plus y plus 4 minus 3x plus y equal to 6. So x minus 3x gives you negative 2x, y plus 2y, and then plus positive 4, move it to the other side, gives you negative 4. So this would equal to 2. Now, I'm going to use the elimination method to solve for x and y. So I'm going to copy this here. 5x plus 2y equal to 16, and negative 2x plus 2y equal to 2. And I'm going to choose subtraction because negative positive gives me a negative 2y in the second equation, so I can cancel this out. Negative, negative, positive, 2x, so it will be 7x. Negative, positive, negative, so negative 2. 16 subtract 2 is 14. X equals to 2. Now I'm just going to use this equation here to find out what y is. So 5 times 2 plus 2y equal to 16. 2y subtract 10 is 6. Y equals to 3. So I'm going to box these. Now I'm going to use a third equation to find out what my z is because it's easier, or the easiest. So 2 plus 3 plus z equal to 6. So z equals to 1. And my final answer is, so 2, 3, 1, alphabetical order. Okay, for the next problem, it's also the same thing, and we just want to do another practice here. Okay, I'm going to isolate the z, or the positive z. So z would be 13 minus 3x minus 2y. I'm going to set this aside. Okay, now I'm going to sub in z for this expression here. X plus y plus 2, okay, 13 minus 3x minus 2y, and then that's equal to 7, so this comes from this part. And then the second one, same thing, 2x plus 3y, and then subtract, and I'm going to sub in 13 minus 3x minus 2y, because that's what z is, and that's equal to 12. And now I'm gonna simplify this. X plus y plus 26 minus 6x minus 4y equal to 7. And then x minus 6x is negative 5x plus y minus 4y minus 3y. And then 7 minus 26 gives you negative 19. Okay, and then I'm going to solve for the second one. That will be 2x plus 3y minus 13 plus 3x plus 2y. So basically I distributed the negatives 1 into every single term here. And this will be equal to 12. So okay, so 2x plus 3x is 5x plus 3y plus 2y plus 5y, and then I'm going to have to add 13 to the other side of the equation, so that's 25. Okay, and I notice that I have a negative 5x here and 5x, so then I'm going to eliminate that. I will write this here. Negative 5x minus 3y equals negative 19. 5x plus 5y equals 25. Second one. And I'm going to choose to add because this will give me a positive 5x here, so I could cancel it out with negative 5x. So positive, positive, so negative 3 plus negative 3y plus 5y gives you a positive 2y, and positive, positive 25, so that would give you a, let's see, 6, and then y would equal to 3. And I'm going to use the second equation to solve for x. So 5x equals to 10, x equals to 2. And I'm going to use this third equation to solve for z. Doesn't matter. 2 times 2 plus 3 times 3 minus z equals to 12. 4 plus 9 minus z equals to 12. So negative z equals -1, so z equals to 1. Your final answer will be 2, 3, 1. During a kayaking trip, a kayaker travels 12 miles upstream against the current. So the current is going in this direction. So, and this guy is going upstream, so that means it's going against the current. And 12 miles downstream with the current as shown in the picture. The speed of the current, meaning this speed, the water, okay, remained constant during the trip. Find the average speed of the kayak in still water and the speed of the current. You're going to have to use distance equals rate times time to find the speed upstream and downstream. So in the word problem, they gave you that the kayaker travels 12 miles upstream. You can do 12 divided by 3 because this kayaker travels 3 hours to find the speed upstream to be 4 miles per hour. And for the speed downstream, it will be 12 divided by 2 hours, which is 6 miles per hour. And then here we can let x equal the speed in still water and y be the speed in the current. So we have two equations here. When this guy goes upstream, it's going to be speed in still water. Subtract the speed of the current. And this would equal to 4. And for this guy, it will be x plus y, the speed in still water plus the current. And that would equal to 6 miles per hour, which is faster because the current will push you to move faster. Versus the first equation, you're going against the current, so it will slow you down. So now we can solve for x and y. Negative, positive, negative, so this is negative 2y, negative, positive, negative, negative 6, so this is negative 2. Y would equal to 1. And I'm going to use this second equation here. It doesn't matter. I'm going to plug in 1 for y. So x will be 5. Let me write my final answer now. Speed in still water is 5 miles per hour, and speed of current is, speed of current is y here, so 1 mile per hour. And this concludes the lesson.